guys, so we are doing the EOC review for math standard 9th through 12th grade coordinate geometry 1.2. So we're given the problem the point -7, 4 is reflected over the line x equals -3. Then the resulting point is reflected over the line y equals x. Where is the point located after both reflections? And so we're given a graph here, and then we're given our multiple choice answers. So the first thing we're going to do is start with the point of where it's given at -7, 4. And we're going to go through the first transformation. So the first one is the reflection over the line x equals -3. So we need to determine which one of these lines is x equals -3. So in other words, we need to find this line here. And how do we know that this line is x equals -3? We know that because no matter which point we select on this line, the x value will be -3. So whether I pick this point, a point here, point down here, the coordinates for all those points would have an x value of -3. So if we're reflecting over this line, our reflection is the same distance away after the reflection has been done as it was before. So to do that, we just count the number of spaces to our line of reflection. So in this case, it is 3. So 1, 2, 3. So 4 spaces. So we're going to go 4 spaces on the opposite side. 1, 2, 3, 4. So our new point is now right here at 1, 2, 3. Our new point is 1, 4. And then from there, the resulting point was reflected over the line y equals x. So we need to do another reflection over the line y equals x, which is now this green line, right? The only other line that was given to us on the coordinate. So when we reflect over the line y equals x, again, the reflection is the same distance away from the line of reflection as it will be after it's reflected. So if we count the number of spaces away, 1, half, 1. We end up at the point 4, 1. So if you notice, we also, when we reflect over the line y equals x, our coordinates, instead of x being 1 and y being 4, our coordinates are now 4, 1, so all they did was flip. So our answer would be D, 4, 1. We'll do one more example on that standard. We pick this one. So if we have triangle JKL and it's being rotated 90 degrees about the origin and then translated using the rule xy becomes x minus 8, y plus 5, what are the coordinates of the final image of point L under this composition of transformations? So to solve this one, the first thing we have to do is take point L, which we can get the coordinates of. So each line represents 2 units. So from the origin to get the coordinates for point L, L would be at 5, -1. So in order to do a rotation of 90 degrees about the origin, we need to know the rules for rotations. So our rule for a 90-degree counterclockwise rotation around the origin is xy becomes yx. So just rewrite it down here. L at 5, -1. To follow the rule yx, it would become -1, 5. And then from there, we need to do our rule for, let's see, and our rule for our translation. And our rule for translation was the x value decreases by 8. So we have -1 minus 8. And our y value of 5. Our rule told us we were increasing by 5. We would add 5. So our new x and y values would be -1 minus 8. End up with -9. And 5 plus 5, we end up with 10. So our L prime point would be at -9, 10. So after the composition of a rotation of 90 degrees around the origin and then the translation, we would end up with point L